Okay, and we're back for problem number 5. This one is about the intermediate value theorem. And the intermediate value theorem, it's such a simple theorem, and I'll explain it this way. If you have 2 points A and B, and there's a line between them, and you want to connect from A to B, the intermediate value theorem just says that if you draw a line that's continuous, then no matter how clever you are, at some point it has to actually cross the line. That's the intermediate value theorem. But if we look at this mathematically, what we're really talking about is a function. This is y equals f of x, and that has to be a continuous function. It doesn't have to be smooth, but if it's a polynomial, it's smooth. And here's the y-axis, here's the x-axis, and this point A has coordinates x1 and f of x1, and point B has coordinates x2, f of x2, and this line that they're crossing, this is actually the line y equals some number k. And the statement of the intermediate value theorem says that if f is continuous for x between x1 and x2, and k is between f of x1 and f of x2, if k is intermediate between those two y values, then guaranteed by the intermediate value theorem, there is some x value c between x1 and x2, so that f of c is equal to k. And so if here's that point, that's going to be c comma k, which just means that f of c, if the input is c, the output is k. Okay, that's all that it says. It says that you can't go from A to B without crossing that line. And it seems natural enough, but it's actually very important in the development of calculus, and so we call it the intermediate value theorem. So let's see if we can fit this problem into this small space. I'm going to move over to the other side. Let me move over here, and yeah, this is comfortable. And let's see where we are. So we have a function, this function f. I'm going to write an xy chart, and I want to know what's happening between these two x values. So here's 1 and 2, and if you put in 1, that's 1 to the 5th minus 2, the y value is -1, and the y value for 2 will be 32 minus 4, that's 28. And so if I try to graph this, here's x, here's y, then I know it goes through this point, 1, -1. This is 1, and let's say this is 2. It'll go through this point, 2, 28. And this is a polynomial, so it's a continuous. In fact, it's even smooth. The graph is smooth. And so if I just connect these, no matter how I do it, I have to cross the x-axis. So y equals 0 is the x-axis. That means that there's some number c, so that f of c is 0, and c is in between 1 and 2. And that's all it is. Just if we have a function that goes from negative to positive, and it's continuous, then it has to cross the x-axis somewhere in between. That's it. Number 5. Let's see. I think we're going to go on to number 6.